Hi people! Did you know that shadows can actually attract each other? Today we're going to be exploring this phenomena. As you can see here, the shadow of my finger when I move my hand is being attracted by the shadow casted by the window's frame. Meanwhile, my hand is not physically touching the frame. Even weirder, when I put my hand in front of the frame or further away from the sun, the hand's shadow appears to be attracted to the frame's shadow. But when my hand is behind the frame or closer to the sun, the frame's shadow seems to be attracted to my hand's shadow. Here, when both of the shadow of my hand and the shadow of the frame seems to be attracted to each other, my hand is physically touching the frame. So, how does this happen? Well, first we would have to know more about the shadows. Shadows from sunlight are constructed by an umbra and penumbra because sunlight is a light source that emits light to every direction. The red line and the blue line represents the maximum diameter of which any amount of light can be blocked by the object. The yellow line and the purple line represents the diameter of which all direct lights are blocked. Between the yellow line and the blue line, or between the purple line and the red line, some lights can be blocked while some can go through. We call that area penumbra. While between the orange line and the purple line is called umbra. At the very start, I thought that the attraction happened because of the overlapping of the two penumbras that formed a part of the shadow that is as dark as the umbra. This makes it look like that the shadows are attracting each other. However, I immediately realized that this theory is wrong. The reason is simple. If two penumbras overlap to make a darker shadow, then the darker shadow should be formed in between the two umbras first. So this theory barely explains the phenomena because nothing in it would give a visual effect of attraction. I tried to modify the first hypothesis. Since the thickness of the penumbra is affected by how far the object is away from the surface its shadow gets projected on, I tried thinking in this direction. Say there are two objects, one further away from the surface of shadow projection and one closer to the surface of shadow projection. This makes one penumbra thicker than the other. We can assume that the thick penumbra is constructed by 5 layers with different brightnesses, and measure the layers' brightnesses with numbers 1, 2, 3, 4, 5. We can also assume that the thinner penumbra is constructed by 3 layers, 1, 3, 5. If the darkness of the umbra is 6, then as the two penumbras overlap and finally one overlaps with 5, a part of the shadow with darkness being 6, as dark as the umbra is created. This part of the shadow would be bulging out from the shadow with thinner penumbra. And this creates a visual effect of attraction. However, there's one part of the phenomena that cannot be explained by this theory. That is, when shadows start attracting each other simultaneously, my hand's shadow gets projected on the frame, or it was circled. Since the umbra of my hand's shadow is already projected on the other object, when the shadows are attracting each other, there's no way that the visual effect of attraction is caused by the intersection of the penumbras. So the next theory must include and be based on how one object's shadow gets projected on the other object. When shadow gets projected on the object, it basically means that the light from a light source is prevented from hitting a certain area. When an object comes in and blocks a part of the light source, the line that marked the area of the umbras and penumbras shift positions like the following. Here we have the original diagram of how umbra and penumbras are created. So these are the penumbras and this is the umbra. So when an object blocks some light source, the original maximum extent of the penumbra, as shown in this diagram, actually decreases. At the same time, the original maximum extent of the umbra, as shown as well, has increased. This visually looks like the shadow is bulging out or being attracted. Also, since the light that comes from this part of the light source is being blocked by an object, it actually casts a shadow on the object that is behind it. This theory actually perfectly shows how shadows attract each other and explain every part of the phenomena beautifully. And here's a video demo that's probably going to make you understand this theory better. Just pay attention to the blue and green lines that mark the umbra and the penumbra, and how the movement of the blue lines affect the green line's position.